Hello everyone, good evening.
Hello, sir.
Good evening.
Sir. Good evening, sir.
Hello, sir.
Okay, so today we have revision session for week 4. Along with that, we will also go through some of mock doubts if you guys have any. Okay, so how many of you have attempted the mock
Sir, attempted.
and how was it?
Yes, sir.
Sir, I have doubt in mock 1, question number 1.
We will go through. Okay, before going through mock, what about week 4? Are you guys comfortable with week 4 or shall we go through week 4 first and then come to mock?
Sir, week 4.
Week
Week
4
4.
first. Sir, week 4.
Also cover big three, sir. Also big three, sir.
Week 3 we discussed complete in last session only. 2.5 hour we spent week 3, so you can go through it. Okay. Share my laptop first. Smite. Okay, great.
Sir, before you start, I just want to
Yeah,
ask you something. You are gonna summarize week 4 first, right? Then you're gonna take
yeah,
doubts. Okay.
yeah. Okay. Yeah. Okay. Mm. Yeah, so mock, I think I'm assuming you all have
Sir, week 3?
covered it. Week 4 we did it in last session only, right? Last session we had on I think last Saturday or Sunday we covered week 3 completely. Okay. Yeah. And for mock, I think we will share a session with you like of previous term where we discuss the complete mock as well, or we will take out some doubt as well, depending on time. But let's focus on week 4 first. Okay. Okay. So week 4, basically we will talk about association between two variable. What do you mean by association between two variable? Association between two variables. Okay. So does anyone what do you mean by the term association between two variable?
Sir, kind of relation, something like
If one variable is correlated with other.
Yeah, we are going to find out some if there is a relationship between two variables or not, right?
Means something like dependency.
Yeah, dependency. Okay, we can also say dependency. Yeah. Okay. Okay. So what two variables I can have? Like we have studied the types of variable, right? Categorical, numerical. So what are possible pairs we can have for this?
So two
We could have
categorical variables,
yeah
two
two
numerical
categorical.
variables, and one categorical and one numerical.
Okay, great. Two okay, two numerical, right? Curl and last one is one categorical and one numerical, right?
Sir,
Okay, let's talk about two categorical first.
Sir, there's a background noise. Can you mute everyone?
Okay, yeah, sure. Let me do that. Okay, that's fine, I think now. Okay, so we are first gonna focus on two categorical variables. So, okay, but okay, let's start with some data set. Okay, So let's take some random things over there. So okay, let's take. Okay, so suppose you went to a town. Okay, you went to a town and you just gonna survey the type of cars. Okay, so you are interested in, is there a relation between, okay, my relation between, by relation I mean association, okay, between type of car purchased and gender, let's say, okay, and gender. So suppose you went on, okay, let's me draw it, or before that, okay, let's first you had this tabulated data, let's say, okay, so here you are making two columns, gender and type of car. Okay, okay, so suppose you went to first person, so gender was, let's say, male, type of car was SUV, then next was female, type of car was sedan, then one could have hatchback, again female, then male again had SUV, and so on, right? So you have collected a lot of data, right? Depending on how many people you have surveyed. So based on that, you try to make a contingency table. So contingency table is where we try to get the frequency of both variables, or you can say the intersection of both variables. Okay, let me tell you what do I mean by intersection. So suppose this is our table, right? So in you can, okay, let me just write it down first, then we will discuss. Type of car I'm writing here, and gender I'm writing down. So male, female. Let's say we have 3 SUV, sedan, and 1 hatchback. Okay. So here I'm putting males and females row wise and type of car in columns, but you can interchange. Okay, so you can have male gender and as the columns and type of car as the rows. So in that case, your contingency table will have 3 rows, 2 columns, right? So while here we have only 2 rows and 3 columns, so you can interchange. It's up to you. So from the table, let's say you notice that there are 10 males who have purchased SUV, right? So from this data set, originally we had this table, right? This kind of structured data. We note it down. So from this, I'm trying to convert it into the contingency table. This is called as contingency table. And from this contingency table, I'm trying to visualize the kind of intersection thing, right? How many males have bought this type of car? How many females have, like it's kind of intersection of female with the SUV, female with the sedan, female with the hatchback. Similarly, male with the SUV, sedan, and hatchback, right? So we're just trying to visualize it. Let's say, let me put some random numbers. Okay, I'm just putting in some random entities. So it's nothing. Okay, let's say 25, let's say 10. Okay, I'm just putting in some random values. For to make calculation easy, let's make it 10 again. Okay. Okay, so from my structured data, I have switched to contingency table, right? So now my major focus is to identify the relation between type of car and gender, right? So what should happen? Like if there is a relationship, what should happen? And if there is not a relationship, what should happen? According to you, anyone? What should happen if there is a relationship and what should not happen? Okay. How would we identify if there is a relationship?
So
The
if
relation
the
all the
Yeah.
rows are same, then there is no relation. And if it's different, then there's a relation.
No, that's something. Okay. What do you mean by there is a relationship between
We'll check
the two?
outliers.
Okay. Where does outlier come from? Oh,
Or means
If
if
the
one increases while other decrease or something.
if the relative
One
if
will
the
be
relative
One has to
frequencies
be
are in the
than the
range,
other.
Okay, let's not go into the relative frequency term for now. What does it actually mean? Okay, suppose I'm telling you there is an association between type of car and gender. What does it mean?
If there is any,
But
if a purchase of car is to do with the gender or not, we
Yeah.
are supposed to find with.
Okay, suppose if there is a relationship, okay? If there is a relationship, okay, so from this relationship, I can figure out which type of car. Suppose in market you are going to launch a new SUV, right?
So
So
one variable varies and another variable should vary.
yeah, so suppose I'm launching a new SUV, right? Suppose we are launching it, and from my data, I know that males are the one who prefer the SUV the most as compared to females. Let's say we had such data set and we concluded that there is a relationship, right? There is an association. If it is SUV, it is most preferred by the male. If I am really launching a sedan, I know that females prefer it more over the female. That's over the male. That's what our data said. So when you are going to do the advertisement next, you will know what's your target audience, right? For
So
SUV, you will
SUV is also preferred by female. They are 15 and male
no,
are
no,
10.
yeah, we are just assuming,
Okay, okay.
just an assumption. Okay, so that's what association mean, right? So if there is an association, it means there are some specific types of car which are preferred more by one gender and not by other, right? There's one gender type which prefer one type of car more as compared to the other. That's what the relationship is. If suppose SUV is preferred by both equally, male and female, so it doesn't matter. You don't have to, specify any gender to advertisement. You can advertise it in general, right? Because they don't have any relation. It doesn't matter whether it's male or female, so you can generally promote it. But if you know that there is an association that male prefer SUV more, so you will target the male audience more, right? So that's what we meant by this association thing. Okay. Any doubt in this?
No,
Okay.
sir.
Okay. So now how do we find it? Okay. So
Here I have to ask one thing, sir.
yeah.
In contingency table, in the lecture it was taught that we put the first variable into the row and the second variable into the column. How do we
Yeah.
come to know which one is the first variable and which one is the second?
Up to you. Whichever you want to consider as first, you can. That's what I mentioned. My contingency table is 2 rows, 3 columns, right? But if you interchange the two, yours would be 3 rows and 2 columns. It doesn't matter. Both would be the same.
Okay.
Okay.
Okay, sir.
Okay. So we have two methods to do it: row relative and column relative frequency. Both will give you the more or less same result. Okay. So I'm going to continue with row relative for now. Column relative, I will leave it for you to do it. Okay. So before that, I need to identify what's the total. How many total males we have over here is 40, right? And females we have 15, 40, 50, right? And in total we had 90. We observed 90 people, of which 40 were male and 50 were female, right? Okay, so let's find out our row relative frequency. So how do you find, do you know how do we find relative frequency first?
Yes, sir.
How we used to find relative frequency, how we do it? Frequency divided by total frequency, right?
Total frequency, yes.
So here when I am saying row relative frequency is for each row we are going to find relative frequency. So if you focus only on our first row, but total frequency is 40, right? And
Yes,
each
sir.
of this SUV, sedan and hatchback have respective frequencies 10, 20, 10. So I can
Yes.
find their relative frequencies, right?
Yes, sir.
Okay. Let me do it. I will just write it in the same continuation. Okay, so what is 10 over 40? It's going to be something 0.25, right? And 20 over 40, it's going to be 0.5. And it's again 0.25, right? and you can check it satisfies the property of relative frequency. If you add it all, it will come out to be 1, right? 0.25 plus 0.5 plus 0.25, right? That's the property of relative frequency. Yeah. Okay.
So,
Then
row relative frequency is what that we can also call proportion.
proportion, the proportion of what you will say?
Like in previous class, Prashant sir has also told, like it was a question there regarding contingency table only.
Mhm.
So they have asked the proportion, like this was the question, SUV something. So they have asked that how many cars male have,
Hmm.
like that
Okay.
proportion. So he told that relative frequency is proportion, and when we multiply it by 100, that then it become percentage.
Okay.
Like I'm
Okay.
asking just that is it relative frequencies are proportions too?
Okay. Yeah, it is a proportion, but proportion of what? That we should specify. Okay. So one thing, let me clarify. So proportion always lies between 0 to 1 firstly. Okay. So whenever we ask proportion, you have to input only from 0 to 1, unless and until it's mentioned percentage. Value of percentage lies between 0 to 100, right?
Okay.
Okay. So percentage. Okay. So if I say what is this 0.25, right? So is this 0.25 is in total I had 40 males, right? Of which
Yes.
10 bought SUV, 20 bought sedan, and 10 bought hatchback. So of these, of all the males, right? I'm focusing only on my first row. My first row is all the males, right? Of all the males, there is 0.25 proportion which bought SUV, right? So proportion of males which buy SUV is 0.25, right? It is a proportion, but you need to be specific what proportion it is. Right?
Okay.
Yeah. So I think activity 4.1 is completely based on it only. You need to find the proportion, right? Okay. Moving further. Okay. What about our second row? It's 15 over 50 would be something 0.3, right? Okay. It's again 0.50. It's again 0.0. Okay. Great. One thing just to be sure, whenever we are finding row relative frequency, you see that there are 2 rows only in my contingency table, right? So we deliberately input third row, and we also take into count this row also for our calculation purpose. Okay. I think I've drawn it a bit badly. Okay. So total would be 25 over here, right? It would be 45. It would be 20. So you also need to compute this. So for my total row, right, it would be 25 over 90. Okay, can anyone tell me the value? 25 over 90, it would be, I think, something around 0.27, right? 0.28, I can say. And remaining would go to 0.22. Okay, you can check it if it's correct or not. Okay. Okay, so we got this value, right? So we got my row relative frequencies, right? So if I'm launching a SUV, let's say, right? 25% of my males would prefer SUV. 30% of my females would prefer SUV. And for sedan, there is nothing, right? It's almost the same. It doesn't matter. It's not depending on gender in general, right? It's same for the both. Hatchback, okay, I can say that males prefer it a bit more, right?
Sir, here SUV and sedan are not, these two variables are not associated.
Which two variables?
So, sedan and SUV.
Sedan and SUV.
is
No,
not
we have found
not associated because relative frequency of sedan is the same as the SUV frequency is changing.
okay, let me write it down. Okay, so we have complete row relative frequencies, right? So in row relative frequencies, we do comparison column wise. Okay, just remember it. Why we do it column wise? Let me tell you. Comparison and column relative, we do row wise comparison. So I'm focusing on row relative frequency for now. You can discover column relative bit on your own. Okay, so yeah, we have this now. Okay, suppose you are launching an SUV, right? You got these value 0.25 and 0.30, right? For sedan, you got 0.50 and 0.50, and then we have hatchback or something, right? And we have 0.25 and 0.20. Okay, so decision, it's kind of very subjective. Some other person can come and say that for me 0.25 and 0.30 are very similar. I don't bother to come, consider them as same. For some, they might not consider it as similar, right? So in quizzes and exam, you won't be getting such ambiguous boundaries. You will get clear difference or no difference at all. So yeah, let's not. So, but in practical life, you will see examples like that, and two different person might have different subjective opinions over the similarity. So you see, if this is an SUV, there are 0.25 proportion of my males preferring to buy it, right? And females, it's 0.30. So do you think females prefer sedan SUV the more over the males?
Slightly.
Slightly, right? Okay. So I can say that if I'm launching SUV, I should target females, right? Okay. What about sedan?
Equal preferences.
Equal, right? Okay, let's make it same. What about hatchback? It's
Male.
it's same, right? Because in the first you are saying female, and third you should say it's male. Definitely, difference is quite same, right? Okay, so you see that there is some relationship between gender and the type of car they have purchased, right? If the person who's buying is female, there are more chances that she will prefer SUV, right, over the males. For sedan, it doesn't matter, and for hatchback, it would be male who would prefer it more over females, right? So I can see that these two variables are in some sense related, right? So in row relative frequency method, we compare the column value of our columns, right? And find out that yes, there is a difference. These frequencies are not very quite similar. There is some difference. So there is something with the categories of first variable that affect the values of my, you can say count of my categories of second variable, right? So that's why whenever my row relative frequencies are not same, we say there is an association.
So I have a
Outside the,
doubt in this.
yeah.
So hatchback has a 0.25 relative frequency, and SUV is also having 0.25
Yes.
row relative frequency. So does it matter? Like we'll see only the one value after that, or two values also?
What do you mean by one value and two values?
Like 0.25 and then 0.50, and then again 0.25 is there.
No, it doesn't matter, right? I'm comparing only columns. I compared my first columns, right?
Okay,
Here
so
I
for
noticed that,
association we compare columns.
yeah, for row relative frequencies, we do column wise comparison, right? That's what I mentioned. And for column relative, we do row wise comparison.
Okay.
Okay, because see, this is my SUV, right? There are 25% of males who prefer SUV, right?
Yeah.
And I'm looking for SUV only. So there are 30% of females who prefer SUV. So there
So,
are
sir,
more
if
chances of female buying it, right?
sir,
Yeah.
if this question comes in the exam, what should be the
Yeah.
answer? Relationship exist or not?
It exists,
It
right?
will exist.
Association exist or not?
Yeah, it will
Association
exist.
is there. That's what we did, right?
Okay.
Because the
मतलब
values are different, not the
Yeah.
same.
Okay.
Association is here because the male, for if you see that like SUV, female prefer SUVs more than as compared.
Yeah.
And in third column, if we see that male prefer hatchback as more preferred. I mean, male prefer SUV as compared to female. So that's why we are saying that the first variable, which is gender, is associative with our second variable.
Hmm. Okay.
But we are seeing here that second column is the same and not.
Yeah. That's what I'm coming to, right? So suppose here we had 3 columns, right? Suppose I had 2 rows again, right? One row male here, female here, and now I have, let's say, 5 columns, right? It means in my second categorical variable I have 5 categories, right? Even if in even if for only one single column the values are not similar. Let's say this is my first column, second column has these value, third let's say again has this 0.25 and 0.25, and fourth let's say also have same 0.20 and 0.2. Then also there would be association because my one column is different. So suppose you have n columns and even for one column the row relative frequencies are not similar, you will say there is an association because at least one category is making a difference, right? Even though my second column is same, I still have one different column, right? In this case I have 2, but even if there is one different column, we will say there is an association because there is one category at least which is making the difference, right? So we say that there is an association. Okay. Any doubt on this?
Hello,
Yeah.
sir.
We need to
Here
keep
in
at least
male and
one
female
column.
category, we calculate the relative frequency. Since there is difference between relative frequency, at least in one column, so we can say that there is a association, right?
Yeah. Yeah.
Okay.
Yeah. So even if one column is different, we say there is an association. Okay. 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 Any doubt in this? Okay. Let's move further then. Okay. So we have did it for 2 categorical variables now, right? Coming back to second point, which is, let's say, 2 numerical variables. 2 numerical variables. Okay. In numerical, there is a problem, right? I can have any kind of association, like whatever you can think of. Let's say y is equals to x square. Is there an association between my variables x and y?
Yes, sure. Relationship is dependency is what.
Okay, let's say x to the power 4 plus 2x square plus 5x. Is there an association?
Just for
Yeah.
the relationship.
Sir,
Yeah.
I'm sorry I had a problem with my mic, so I couldn't answer. I have a doubt in the row relative frequency association thing, sir.
Okay.
So when ma'am explained in the video, she said that if the row relative frequency are almost equal to the row total, then they are not associated.
Almost equal to the row total. Okay,
Yes.
what do you mean by row total?
So row relative frequency total. We have the frequency in the male and female, no sir, 0.25 and 0.30.
Yeah.
So it's almost equal to the total 0.28. So it
Almost
is,
equal to. Okay, no. You don't have to go to total further. See, if these two are same, right? If suppose these two comes out to be same, let's say in second column, right? then you can bring out the total one and compare it. See, if you take it all three, right? If you take all three, 0.25, 0.30, 0.28, let's say, okay?
Okay.
So here also, and second column is 0.25, 0.20, 0.22, right? So here you can see that first two values are making a difference, right?
Yes.
Sir,
First
could
two
I
values are
speak?
different. Yeah,
Hello, sir. Could I speak?
yeah, you're already speaking.
सर यस यस ये जो मैडम के लेक्चर्स हैं उसके अनुसार ये जो अगर आपका मेल फ्रीक्वेंसी फीमेल फ्रीक्वेंसी एट टोटल फ्रीक्वेंसी सेम रेंज में है दिस इज द केस हियर आल्सो सो देयर इज नो रिलेशनशिप and I think it is almost correct because the relationship is there is no wide variation.
Sir, actually, if
I
you take
already mentioned it is very subjective. Some might say there is, some might say there is not.
It is subjective, but in the
Yeah.
statistics, if 2% and 3% doesn't vary, means doesn't affect anything more. So if there is a 25 and there are a 35, then we can say there are relation association. Otherwise, there is no association.
No, there is no strict rule I should go 10%. Many of you said
So-
that these are not similar.
So, but sedan
This
is
creates
0.
some type of a confusion.
See, these are very subjective decisions, right? Some might say these are not similar. Some people like you will say it's similar, right? In
I
practical
think, sir,
life,
in the I
So what
think
should we
let me
answer if
complete.
we get such kind of values in the answer?
Yeah, that's what I'm coming to, right? So these are some practical problems which you will see, right? But in if you are looking from quiz perspective, you won't be having such ambiguous value, right? I
okay,
have
then
just
it is okay,
generated some
fine.
random values, right? So we are getting such answers. But in quizzes, you will either see a clear difference or you will see very close value. We don't have any fixed difference, like it should be 5%, it should be greater than 3%. It's very subjective. Many of you say
So,
0.25, 0.30 are same. Many of you will say these are not same. So subjective opinions are open for
We call it
submissions.
not associative. So there should be all the columns should be equal, like the column 2, 0.50 and 0.50. There should be all columns equal, exactly equal. That's why we will then we will say that it's not associative.
Yeah, we do the column wise comparison, right? We compare
Yeah,
first column, second column, and third column.
Yeah. So we have to just check it the exactly same column or not, are there or not. Like second column, it's 0.50 and 0.50. If there is all the column exactly same, equal, so we will
Yeah,
call
then
that
you will
it's not
say
associated.
there's a not association, right? So you can also compare these two. So you can see 0.25, 30 is not same as 0.50, 0.50, right? So
For
it's
this
so
point of view,
as
we have to just check it
0.50
exactly
and
equal
0.
or not.
you have.
I was saying that from this point of view, we have to just check it that it is exactly equal or not. If there is a minor difference, also like 0.25 and 0.33 or 0.25, 0.28, we'll call it its association.
Okay. Let me show you one other way you can visualize it. Okay. So my first column values are
Sir, one
yeah.
second, sir.
Yeah.
The similar example was given in the lecture.
Okay.
Ma'am said it is not associated.
Yes, sir,
And
but
there
then I have
was a
So
question even in
to
the
add to
practice
it.
assignment.
So you're
values might be
calculating
different,
the
right?
relative frequency for this example what you did, but in the video when ma'am did, she calculated the percentage and said that if it is almost equal, then we can say it's not associated. But
Yeah. So
right,
ma'am's value might be different. My values are different, right? I have written randomly. I have not
but
noted
then
it
the
down
values
somewhere.
are almost okay, sir. I'll just tell you one example what she gave. She gave for
Yeah.
female 22.73 and for
Okay.
male 25, and the
Okay.
total was 24.
Yeah. These are same, right?
The
But then
sedan values are
24.
0.50, 0.50, and 0.50. So is it associated?
Okay. Let's not get confused. Well, okay. One way is this. Okay. Let me show you another way to do it. See, the first column values are 0.25 and 0.30, right? Okay. So,
Yes.
okay, should we go by that approach? Let's see. No, I think we can't go by this. Okay, we can't go by this approach. Yeah, sorry. Okay. Okay, please ask your doubts. Yeah. Let me take one
I'm
doubts.
sorry for confusing a lot, sir, but then in the example which ma'am gave, the difference was like 2%.
2%. Yeah.
She actually calculated the percentage, and for the example that you are giving right now, you are calculating the relative frequency.
You can calculate percentage. If you multiply
Yeah.
it by 100, you will get
Yeah,
25,
you
30, and
calculate
28.
both. But
Yeah,
then
you
the
can calculate
difference,
both.
the difference is actually big, right? It's 22 and 24 in what ma'am gave, and you are doing
22.73, right? 22.73. Approximately, it would be 23, right? 23, 25, and 24.
Yes.
So, do you think these values are not close or not similar?
These are close.
So we can't
These are
determine that,
similar.
right?
These are very similar, right?
Sir, if we consider the same for hatchback, it is even that is similar, no sir. If we convert it to percentage, also it is similar, no sir.
It would be 25% and 20%, right?
And even 22% is there, no sir.
No, let's not go to total. Let's stick to only these two. We go to total when these two are very close.
Sir, but
So,
ma'am
sir,
had
what
considered even total,
Hello,
sir.
sir.
Yeah, you can
Sir.
consider
just
total.
add
Okay,
1
let's say I'm considering total also. Okay, 22%. Still, these two values are not similar, right?
Can I just add 1 point to what my
Yeah.
doubt? So, for what you're telling is we have the male value and the female value. If our
Yeah.
total value is in between the male value and the female value, then it is equal. Am I right?
No, you don't. Okay, what I am saying is, okay, let's look at the third column. Okay, 25, 20, and 22, right?
Yes, sir.
I'm noting down this value: 25, 20, and 22. Do you think 25 and 20 are very close enough?
No.
No, right? So that's over, right? Even though 20 and 22 are close, this pair is not close.
Okay,
So I
sir.
will say overall it's not close. Okay.
So
Total we
first we
also
check
take
whether
into consideration.
female are close. Then we check if it's equal to the, almost equal to the total.
Yeah. So for sedan, I checked it's 50-50, right? Then I
Okay.
will check it with total. Total is also 50. Then yeah, it's fine. It is
Okay, sir.
possible that I might get 40-40, and let's say my totals comes out to be 40. Then I won't say.
Okay, sir.
Okay. Because my this pair is different, or this pair is also different. Okay.
Got it, sir. Thank you so much.
But sir,
Yeah.
sir,
Yeah.
why do we need a cutoff? We can still say it is related, but it's a very small relation, right?
Yeah. It is. We don't have some coefficient or number to describe the strength, but yeah, it's very subjective, right? That's what I'm
Because
saying. Some of you
because
can consider it same and proceed further. You can say no association.
Is
Completely
it
fine with it.
possible to prove it mathematically? Like
With mathematically, what do you mean by mathematically? With what to prove
like finding
mathematically
the
over here?
relation, you have this strong, weak, and moderate.
Yeah, we don't have it for categorical variable. That's what I'm saying. That's
yeah,
why we have only subjective decisions open here.
I think sir, still even if this is a low value also, we can't ignore it because now the count is okay only 40. Suppose if this is 40,000, 50,000, or 90,000, so then there is a relation, right?
Yeah, that's what matters. If you are, it's you are making a report, it's up to you how you want to present it. That's a decision you can make. It's completely open, and any other person can argue your decision, and that's also fair enough. Like many of you are arguing over here that these two are not similar. That's very fair enough. You can. It's subjective. We are open to that. But when you see some clear difference and clear closeness, don't argue in that, please. Okay. If it's 25-35, I don't think there is a point of argue to say that these are similar, right? If it's 23, 24, 25, there is again no point of arguing that these are not similar. These are similar, right? But for such cases, yeah, you can argue. Could be, could not be. Up to you. It's one's own preference. Okay. So that's the problem in categorical variable. We don't have some fixed measure of association. We make some manual decisions subjectively. Okay.
So here I have to ask, sir, if row relative frequencies are same, there is no association between two variables, between two categorical variables. Why is it so sure?
So, okay, suppose you are launching a hatchback in the market, right? which type of audience would you prefer, male or female? You would give more preference to the male while advertisement,
Male.
right? Because they
Yes,
are
sir,
the
male.
one who want to purchase it. So that's why there's an association. If you are launching a sedan, you won't prefer any gender, you will do it equally, right? In case of SUV, you target females more in your advertisement, right? So there is some association why you are preferring for one specific type of car, you are preferring only one type of audience, right? There is something to do with the two variables.
Okay, if all are same, then they are having the same proportion. That's why they
Same
have
behavior they are having. Yeah, I won't prefer any
So it
one over
means,
the other.
so it means that 25, 20, and 22 are not associated.
25, 20. Yeah, okay. According to you, are 25 and 20 similar or not?
No, that's a
Not
different
similar. Yeah.
person.
Even if one pair is not similar, the overall is not similar. Even though 20 and 22 are close enough, but this pair is not close enough, right?
Okay, yeah.
So I would say that there is an
Okay.
association because these are not same or
First we will
similar.
see instead of total. Then
Yeah,
we'll
you can
see
check
that.
any pair you like, you can check. Okay.
Okay.
Sir, but
All
in
all
exam,
three
sir,
pairs should be same. Yeah.
sir, in exam, the row relative frequency comes out to be like 22.73, 25, and 24. And what will be the
In
answer?
exam, such cases won't be there. It would be very clear-cut difference or very clear-cut closeness. We won't give you such ambiguous question. We are aware of such things, such possible answers, right? We won't give you such ambiguous question where you can have multiple answers correct. Okay, so I have generated, I think I didn't generate good random numbers to distinguish much, but yeah, it's fine. Is it clear now? Or any doubt in this?
No doubt, sir.
Yes,
Okay.
sir.
Okay, coming back to our numerical. Okay, so what's the relation in y equals x square? Quadratic relation, right?
Y is dependent on x.
Here also these two are related with some polynomial of degree 4, right? Polynomial degree 4, right? So for this course, we are gonna fix the relationship to be linear. We will only check if the association is linear or not. Even if it's quadratic, we won't be able to find. Okay, we will only check for linear. Okay, but linear is the simplest case to check for. Okay, so okay, let's say you have two variables x and y again. Okay, let's say these are my two numerical variables x and y. Okay, and I have some values for both of them. So first thing you can check is you can do some visualization to check. Like in real life, it's very fair enough to go by visualizing first. Right? Suppose I'm plotting x on x-axis and variable y on y-axis, and I got something like this. These are, let's say, my data points. Can you see some relationship between the two?
Yes, there is a
Yes.
Yes, sir. As x increases, y also increases.
Yeah, I can see a linear relationship, right?
Yes.
Some kind of linear relationship. Okay. Let me change the plot. Okay. Let's say again, I have some two variables x and y. Okay. Okay, let's say this is my, let's say, data set. Is there some relationship between x and y?
Yes, it is there, sir, but it
Yes,
is
sir.
not linear.
Quadratic.
Yes, yeah, some kind of relationship over here, right? Some kind of like this, right? So by
Yes.
plotting, we can see that there are some relationship. Okay, let me give you another example. Let's say my graph is, let's say, completely full by all these values. Is there any relationship?
Can you please explain this again?
Which part?
Like this linear part only.
This linear part. Okay, so these black dots are my points, right? Are you able to see it? Sure.
Yeah, these are not these are tightly clustered. Yeah.
Yeah, so you can see that as my value of x increasing in this, my y is also increasing, right?
Yeah.
There is some kind of relationship, and I can see it's growing linearly, right?
Yes. Yeah.
Some kind of y equals to x time of relationship we can see, right? If it passes through origin, right?
Okay. Yeah.
In this, there is also some polynomial relationship, right? I can have this curve, like first value of y is increasing with increase in x,
And
then it
then
start decreasing.
reason why
Yeah, okay. What about this?
these are.
Sir, I think there is also a relationship, but very
Okay.
complicated relationship. Mathematically, you
So
can.
this we have to calculate the mean for x and y, and then we'll have to determine the relationship or association.
Okay,
This
no,
correct?
just what about the visualization part? Can you see any pattern like x increasing, y increasing,
No,
any
there is
kind of
no
such pattern?
pattern. There is no pattern.
Okay, so we are not able to see any pattern in this. Okay, so these are
Yeah.
not any pattern. Here we were able to see some linear pattern. Here we were able to see some polynomial pattern, right? So throughout this course, we will only talk about linear patterns. Okay.
Good evening, sir.
Yeah, good evening.
Sir, can I ask one question related
Yeah.
to hall ticket?
Hall ticket, it will be generated, so you can write to support mail. Support team, they will answer such queries.
Okay.
Okay, so we have seen some sort of associations. Okay, so how do we find linear association? We will only focus on linear associations. Okay, so let me just write it down. Linear association. Okay. Okay, so we had actually two terms or two ways to define it. So first one comes out to be covariance. Okay, so what covariance did is, it is like takes the product of deviation from mean of each of the variable. Okay, one thing to mention, it would be n if it's population, and it would be n minus 1 its sample covariance. Okay, just like we had for variance and standard deviation. Okay, so we came up with this thing to find out linear association. We said that we have this measure. So what's the problem in this? We switched to another measure called correlation. What's the issue with the covariance?
It has units, measurable units.
So how does it matter? Like, it's good if it has unit, right? How does it cause a problem to us?
We cannot tell the association directly.
We cannot tell the association. Okay.
You cannot compare between.
Can't find the size of the covariance.
Okay. Suppose I have one data set over here, right? X and Y, and I have another data set over here. Let's say X and Y. So suppose here my unit of X is in kg and Y is in meter, right? So what would be the unit of covariance of X and Y?
It will be
Is
kg
meter.
into meter. Kg meter.
Kg into meter, right? Because my this term would be in kgs and this term would be in meters, right?
Meter.
Okay, but let's suppose for second it's centimeter and grams. What would be a, or let's say centimeter and, or let's say both are kg. Let's not. Okay, let's make it simple. Both are kgs. So what would be the unit of covariance?
Kg square.
Kg square.
Kg square. Okay, now suppose you have computed covariance and it comes out to be 100 kg meter, and for second data set it comes out to be 100 kg square.
Yes.
I compare the two values.
We cannot compare it.
No.
Because it is in different units.
Right? So there is no
Same
way I can get
bed.
kg square to kg meter. There's no way I can go from that unit to that, right? Even if it's centimeter gram, I can convert in some way. But kg square to kg meter, it might not be possible, right?
Yes.
Yeah.
Not possible comparison. So I cannot tell whether this data set, this kg meter data set has higher association or this second data set has good association as compared to first one. I cannot compare, right? No
Yes,
comparison.
no comparison.
So we need one other measure which don't have units.
Yeah.
Right?
Correlation.
So we came up with correlation. Right. So let me write it down. Yeah. Okay. So covariance, you said that you do something like this. You take deviation of each variable from its mean, take its product.
Standard deviation of X and Y.
Okay, this is one way to do it. Other way, and I hope you won't possibly confuse with it. This is one formula. Second formula is take sample covariance of the two variable divided by sample standard deviation of X and sample standard deviation of Y. Or
So in the first formula, is it the standard deviation, standard deviation or population standard deviation, sir?
nothing in first it's nothing, right? It's just
Yeah,
simple
that's
product.
like
Okay. Okay, so population standard deviation I will represent by some sigma. Okay. Sigma X and sigma Y. So one point to note it over here. Either take all the samples, all the three terms in sample, or all the three terms in population.
As
Why?
the denominators will get cancelled.
Yeah, so if you take 1 by n over here, so again I would have here under root 1 by n in this term and under root 1 by n in this term, and that would be 1 over n again, right? So both gets cancelled out. If you take sample covariance and in denominator you took population standard deviations, so that won't get cancelled out, right?
So the upper one will be more convenient and better.
Yeah, it's up to you. Whatever. In some question there might be cases where you know sample covariance and sample standard deviation, so you can directly put in the values. But you need to be sure that all three are sample ones. If either one of them is population, you cannot plug in the values directly. You have to get it all to sample or all to population, right? Just for a case, let's say you know sample covariance. Okay, you know this value, right? You know sample standard deviation of X and you know population standard deviation of Y. So first you need to convert it into sample standard deviation of Y. How to do that? Recall week 3, right? We did week 3 before week 4 for a reason, and that's the reason. You should be able to convert. So once you convert it, and then you can plug in, right? So be sure while plugging in the values that these all are either sample, either population, or if you don't want to confuse it, just directly go with the first formula. Okay. Okay, so correlation coefficient is generally denoted by small r. Okay. Okay. One more thing. What's the range? Okay, so its minimum value it can take is -1, and maximum value it can take is +1. Okay, it cannot go beyond that. That's another interesting thing about it.
so. So may I ask a question?
Yeah, sure.
I came across this question, sir. Shall I read it out?
Yeah.
There is a strong positive correlation between the marks obtained by students of class 10th and class 12th in statistics. If the population standard deviation of the marks obtained by students of class 10th and 12th is 2 and 5 respectively, then which of the following is or are could be possible value of the population covariance between
Yeah. Yeah, I made that
the
question.
of 10th class 12 6? Yes, sir. So the options are 7, 8, 9.5, and 11. Could you please
Yeah,
help
I think
me
this
with
is previous qualifier question somewhat, right?
Yeah. Yes, sir. Yes, sir.
Yeah. I designed that one. Okay, so we will do that
Okay.
also. Okay, yeah, we will
Yes,
do
sir. Yes, sir. Thank you. Thank you.
that. Before that, okay, so this is the range for -1 to +1. Okay. Okay. So okay, one quick question. Can my denominator can ever be negative?
Never.
No, sir.
No, sir.
Yes, sir.
This would always be positive, this will always be positive, right?
Yes.
So it means the sign of correlation depends on sign of covariance, right?
Yes.
Sign of correlation would be same as sign of covariance, right? So if you know that covariance is negative, so you will get an idea that your value of correlation coefficient would be negative also, right? It can never go positive because in denominator you will have only positive term, right? Okay, let's switch to next part. Okay, so I mentioned you that the range is somewhat -1 to 1, right? So we have split down this range into some parts. Okay, one thing to be clear about is the ranges which I'm going to tell you, it's again very subjective. Some textbook might give you other range, some might give you different than that. But for stats 1 course, you need to stick to these ranges only, okay? -1 to 1, let's say 0 over here, 0.25, 0.50, 0.75, okay? -0.25, -0.75, and -0.50. Okay, so suppose you have computed the value of r, okay, and you see that it belongs to this area. This black region. What is this black region? It's not touching 0.25 exactly. It's less than -0.25, but it's greater than -0.25 but less than 0.25, right? So in such cases, we say that there is
No association.
Association. Peak association.
Absence of linear
Yeah,
relationship or
there is
linear
no
association.
linear relation.
Okay.
Yes.
Yeah. Okay. Next we split down to this. Okay. It will go on from -0.25. It's touching the -0.25 area. It's touching the 0.25 area, and it's this region only, right? So if it's in this region, right? This region is okay. I will write it in terms of absolute value. My absolute value is greater than or equal to 0.25 but less than 0.5. Then we say there is a weak linear relationship, right?
Sir, if there is 0.25 also, it will be weak.
Yeah, for 0.25 it will be weak. That's where I put equal to sign, right?
Okay.
Okay, next is it touches 0.50 and goes on till 0.75 on both sides. So again, in terms of absolute value, if I write, it would be this. So it's moderate, right? Moderate linear relationship. In some textbook, you would find it out it's going till 0.8, and some it would go on till 0.7, 8.82. But for stats 1 course, and even for quizzes and grade assignment part, I am expecting you to stick to these ranges only we are mentioning. Okay. Okay. Last part is this, the leftover region, right? It can touch -1, it can touch 0.75 to 1, right? So if my absolute value of r is in this, we say it's strong linear relationship. Okay. Okay. So, and suppose my value is -0.47. It means there is weak linear relationship, right?
Yes, sir. Negative.
Yes.
And it's also negative. Okay. Suppose I got value -0.22. What would it be?
Absence of relationship.
Absence of
linear.
And negative?
Yes.
Yes.
If it's absence, how can it be negative?
Yeah,
Either it's negative,
it's no relationship. Yeah.
no relationship, right? So
Can't be
don't say
negative,
it's
can't be
negative.
positive.
It's only absence. It can neither be negative or positive because you are saying there is no linear relationship, right? Then how can you say it's going to be positive or negative? Okay, coming back. Okay, are you clear with the ranges? Or any
So
doubt?
when will be the hall tickets released?
It will be released soon. Okay. Is any doubt in this part?
Okay, sir.
Okay, I will take it as a no. Okay. Someone asked the question. I think it's previous qualifier question. Uh, okay, so the question said that you have some marks of class 10th, okay, and you have some marks of class 12th, right? And you know that I don't know the sample standard deviation is 2 and sample standard deviation is 5. So I'm saying this class 10 marks is variable x and class 12 mark is variable y, right? And it is given to you that there is a strong linear association.
So it is population standard deviation.
Population, okay.
And we have asked to find the population covariance.
Okay, and one set it could be population. Okay, let's stick to that. Okay, population, right? So you need to, you know, there's a strong linear association. The whole point of question is hidden in this part only. What do you mean by strong linear association?
It's 1.
Strong.
So
It means
if the correlation's value is in between 0.75 to 1.
0.5 to 1, right? Okay, since okay, it's the absolute value, right? Absolute value, right?
Yes.
Okay, what's the formula for correlation? It's
My x1
covariance xy divided by, I'm taking population covariance, right? Because I'm taking population standard deviations in the denominator, right? And my denominator is always positive, right? So my absolute value is only in the numerator now, right? Right? Yes. Okay, now I can plug in the values. It's 2, it's 5. So my denominator becomes 10, right? It implies that my population value covariance between the two variables lies between 7.5 and 10, right?
Yes, sir.
Yes, sir.
And what are the options given in the, can you tell me who asked this? I think one was 11, one was
7, 9.5 and 8.
And 11, sir.
7, 9.5 and 8. Okay, so which of these values lies in this range? 11 lies in this range.
No, sir, it's greater than 1.
So it's, yeah, 9.5, yes.
Yeah,
7,
it is 0.95. 7 won't
8.
lie. 8 will lie.
So these two will be the answer, right? Okay. So yeah, expect such conceptual
Yes, sir.
questions in this time.
Sir, can you repeat, please?
Sir, similar one more, sir.
Similar one more. Okay.
Similar in the sense, like two means were given and two variances are given for two batches. So they want the total, what do you call variance? Like two teachers were correcting a certain number of papers, and what happens is first set of papers corrected by teacher one. They are given n as 20, or rather they are given n and they are given the mean, and also they are given the variance. Similarly, for second set of
again the same
teachers.
question. I think the September term qualifier or something, right?
Yeah. So yes, sir. They are asking for the total mean and the total variance. Mean I was able to do it, but variance I'm not able to do it, sir.
So shall I read out that question?
Okay, no, it's again me who wrote it. So
So,
okay.
so where
Okay,
do I
sir.
get
Okay,
this
okay.
previous qualifier questions?
I'm not you. I think most of you guys are having some in Telegram group or something. I think you all can share among yourself. Okay, so that part is from week 3. In the end, we will try to do that question. Okay. Mean part you are able to do, right?
Week 4. Yeah.
Yeah, variance
But
part.
okay. Okay,
Yeah,
we can do
variance.
it, sir, but calculating this variance and standard deviation with a set of some 5-6 data with squaring and taking that is really taking a lot of time actually.
Yeah, so during that time, I think
Calculator is
we.
given.
No, okay, so yeah, during that exam, we kind of I think gave marks to all because the question went on to difficult levels. So yeah, we will do it if we get time in the last. So if you are able to calculate mean, it's okay. If you're struggling with the mean, we can do that. For the variance part, we can wait till the last because it's not that of major thing for the course now.
Sir, okay.
Yeah. Okay. Yeah.
Sir, one more. I mean, after finishing, whenever you have, you can ask me, sir. Mock 1, I have a problem. Question number 13.
Okay. Yeah. Mock we will come to. Let's just conclude. Okay. One
Yeah,
quick
yeah,
question.
after
Okay.
that. Yes, sir.
One quick question. I will, I think, start a poll for it or something. Let's do that. Okay. Start a poll.
Yeah, battery is remaining low.
Okay, okay. Let's just, I think, quickly do it. Suppose my correlation coefficient. Okay, my correlation coefficient is coming out to be 0, let's say, okay? Okay. But quick question. Are my variables independent? Yes or no?
Yes.
Okay. What about others?
If there are two
Yes.
say x
Yes.
y.
Yes.
So can you please
Yes, sir.
explain what do you mean by independent?
Yes.
Okay. And independent means there is no association. Okay, I have opened up the poll. I think you all can answer it, right? Maybe. Yeah, you all can answer it. That's fine. I think I have. Did I make some mistake or something? I don't know.
Yeah, man, it's been there.
Okay, what should be the answer as per all of you?
Sir, it is between 0.25
So there is no
brothers, so there is
association.
no relationship. So they are
Yeah,
independent.
there is no association. There is absence of linear relation.
You are saying that these are independent, right?
Yeah, these are independent. Because it's zero.
Let's
There
close
can
the
be
poll.
relationship.
Okay, so if all of you are saying it's independent, trust me, you are going to lose straight 4 marks.
It can be dependent.
Okay. In the starting, I mentioned something. Okay, let me show you. I mentioned it. Here, can you notice one thing we are talking about? Linear relationship, right? And somewhat where also we said that we will only find linear relationship, right? Between two numerical variables, we will find linear relationship, right? For this course. So suppose my relationship is, suppose I have some this kind of relationship. x square plus
So
5x
isn't
plus
it be
7.
zero if both the values are the on the cross section of the mean?
Okay. Correlation. Wait a minute.
Sir, your voice is echoing.
Yeah, I think someone's mic is echoing. Okay. So r equal to 0. My r is correlation coefficient, right?
Yes, sir.
Correlation coefficient tells me about linear association, right?
Linear association.
So if there is some quadratic or polynomial relationship, will it tell me about this relationship?
So
No, sir.
no, sir,
No,
because
sir.
it is linear and that is quadratic.
It can give me value 0 saying that there is no linear association, right?
Yeah,
But
we
it
all
in no
we
sense
can
means
say
that,
is there is no linear relationship, but there might be some other kind of relationship. That's
yeah.
all we
So
can say from that.
if I say that are my variables linearly independent,
Yes, sir.
Yeah, that we can say,
then
sir.
yes,
That we
that we
can
can
say.
say. But if I'm saying in general my variables are independent, that would
So
be no.
that would be no.
Because
So
there could be
why
some
that
any
will
other
be no?
relationship. Can you repeat?
Why that will be no general variables independent?
Because you see there is some quadratic relationship, right?
Yeah.
But if you compute linear relationship, like value of correlation coefficient, you might get 0 because there is no linear relationship.
Okay.
Okay, so it gives you a value 0. It means there is no linear relationship, but there could
Yes.
be other polynomial relationship as well.
Okay.
So if my value of correlation coefficient is 0, it means they are linearly independent. It does not mean that they are independent in total. Okay.
So they are linearly independent, but not we cannot say that they're totally independent.
Yeah. Okay. Another. Let's reverse this question. Let's twist this. Okay. Someone's mic is making a lot of noise. Again, I should mute you all. Okay. Let's twist this question a different way. If my variables are independent, it means there is no association. And I'm saying independent means there is no association, right?
So can you repeat?
Suppose my variables are independent. It means there is no association between the two, right?
Yes.
Nothing. No polynomial, nothing. Then can I say my r equal to 0?
Yes.
Always.
Yes, sir, we can say.
Yes, right? So notice the difference between the two questions. If my variables are independent, I can say that r can be 0 because if they are independent, there won't be any linear association also, right? But
Yes, sir.
if r equal to 0, then I cannot say these are independent in general. I can only say they are linearly independent. Are you getting the difference between the three statements written on the screen?
Yes, sir.
Yes.
Okay, great. Okay, any doubt in the correlation part before we move further?
Sir, I have a question.
Yeah.
I mean, a question, not about the concept and thing. I don't know how to approach this question. So if you allow me to read it out, so I'll
Yeah,
just do
sure.
it. So, sir, the question says if there are two variables, x and y,
Okay.
each having n data points,
Mhm.
where each data point is obtained by xi is equals to I,
Okay, and y it's ni
n plus I,
n plus I.
n plus I, yeah. What is the correlation coefficient of x and y? I don't know how to approach this question, sir. So if you can help me.
Okay, such kind of questions you can answer just by visualizing. Let's not spend time calculating. X is I, right?
Yes, sir.
So in general, I can say all my would be some I, right? I 1, 2, 3, 4, depending on it, right?
Yeah.
Y would be n plus I, right?
Yes, sir.
So can I write y is equals to n plus x?
Yes, sir. We can write.
N is some constant, right?
Yeah.
Let's say assume any value you like. Let's say n equal 10, right?
Yeah.
Y is equals to x plus 10.
Mm-hmm.
Is it a linear relationship?
It is linear relationship.
Perfectly linear, right?
Yeah.
R is equals to 1,
Oh, okay. Got it.
right?
Okay.
If it's y is equals to minus x plus 10, increase in y will decrease, increase in x will decrease my y, right?
Yeah.
Perfectly linear relationship, r
Yeah,
equals
still
-1.
-1, yeah. Still it would be, yeah, okay, correct.
Yeah. So some questions you can directly by approaching, by making equation or by plotting scatter plot, you can answer directly.
Okay.
Okay.
Thanks.
Okay. Any other doubt in correlation coefficient? Or shall we proceed further? Okay. So two numerical variables we did. Okay. So next coming it one categorical and one numerical. Okay. One categorical and one numerical. Let's move to that part now. Okay. So why do we need to find
Excuse
it?
me, sir.
Yeah.
Sir, actually, I joined a little late due to CT paper. So, other than revision, is there any update for qualifier other than this revision? Any new news, sir?
Was CT qualified during the time of this session?
Yes, sir. 7 to 8, sir. CT mock.
A mock test was scheduled, sir.
Yeah, it was 7 to 8:30.
Okay, did all of you did it or some of you missed it? We can extend the deadline if you want.
We have missed it.
Okay, we will extend the deadline. I will inform them.
We will extend the deadline, sir.
Yeah, I think many of you were in session were not able to do it, right?
Yes.
I didn't understand the initial question. Dependent and independent variables.
Do you have said any new update before this from starting, sir? Other than this revision?
Oh no, we are just doing the revision thing. Any important
Am I
updates we will
audible?
get through announcements only. Yeah, you are audible.
I didn't understand the dependent and independent variable.
Dependent. Okay, what's okay, let me show you that thing on the screen. Yeah, which point you struggle with? Like which statement you struggle with the most? I think we have this. Yeah.
Can you please extend the deadline for computational mock test?
Yeah, I have informed the team it will be increases. Yeah. So what's the doubt? In which statement you struggle? First statement, second, or third one? We have three statements.
Actually, how you are saying that it's independent and
Third one, right?
all three.
This one, right?
All three.
Okay. If my variables are independent, independence means there is no association, right? No association means there is no linear relationship, there is no quadratic relationship, there is no any other polynomial relationship, right? Or any other relationship you can think of.
Independent and no association means that
No association means the increase or decrease in one value will not affect the other values. There is no pattern. Okay, so if there is no association, there is no relation, there won't be any linear relationship also, right? If there is no linear relationship, it means my value of correlation coefficient would be 0, right? So that's what this statement
and
means.
if it's not, if it's linearly dependent,
If it's linearly independent, then also my R would be 0. But if your R equals 0, it means they are linearly independent, right? But it doesn't mean it would be quadratic independent also. It doesn't mean that. So we cannot say they would be independent in general. I can only say they would be linearly independent if my R equals 0. But if they are
we
independent,
said that it's if it is independent, it means there's no association. We said that it's okay. R equals to 0. But if it is linearly dependent, it's the R is equals to 0.
yeah, linearly independent means R is 0. But if they are independent, then also R is 0. But R equal to 0 does not imply they are independent. Okay, just note down these three statements, okay, and just try to think
Excuse
on
me,
it and
sir.
go through this part of session on YouTube again. Yeah.
So, as I am a student for the direct diploma entry, so
Okay.
I don't have any subject computational thinking. But
Okay.
in the mock, I find out two questions of computational thinking in stats. So in my quiz
It's
also there will be computational thinking.
no, there won't be. But I think mock is same, right? For everyone, you want to be seeing two
Yeah,
computational things.
mock is same for everyone, but in quiz one I am asking that it will be
No. You won't see. You will have sections. You have to select which section you want to answer. So select stats one.
okay. Okay, thank you.
Okay. Next is we have one categorical
And sir, today was deadline for admit card, but we yet not received that, sir. Is
you will
there
receive
some
it.
error?
Okay. Yeah, it could
It,
be
Said
delayed.
that
sir,
they
it
will
is
send
available, sir. It is available,
If
sir.
it's
Why
it
available,
on
it would be.
13 or after 13 hall ticket will be available.
Okay.
But
No,
it's
It's
not
before
there.
13 and 13. But
Yes,
13 is not full.
yes, it is available. Just log out of your portal and log back in again. I just did it and I can see that.
okay. So just try that out.
It's not
And if you're not
available
good,
for everyone, sir.
yeah, if it's not available, it would be made available, right? It would be if you didn't get it by tomorrow morning, just mail to support and they will provide you. Okay, we'll look into it.
Okay, sir. Okay.
Okay. Okay. One categorical and one numerical. Okay. Uh, there would be possible, right? That you might have a that question might be similar to grade assignment something, but okay, let's see. Okay, so for this course thing, we will only stick to those categorical variable which have only two categories. Okay, we won't take categorical variable which have more than two categories or have only one category. So we will only stick to categorical variables who has two categories. Okay, suppose you are launching a new car, let's say. Okay, you are launching a new car. And you are confused whether to like in which city to advertise more, whether you want to advertise more in Delhi or you want to advertise more in Mumbai, right? So you are confused between the two. But in some sense, if you can find there is some association, okay, if you can figure out that you will be benefited more if you advertise in one city as compared to other, it means that the city might have something to do with your sales, right, of new car. If you are able to prioritize one city over the other in your advertisement marketing thing, it means there is some association which made you prefer one city over the other, right? So let's say we have this data. I'm just gonna take some categorical variable. Let's say it's city, and let's say it's sales. So you notice down you collected some data of previous. Let's say D for Delhi and M for Mumbai. Let's do it. Okay, D and M. Okay, let's make it 5 data points for now. Let's say sale is in lakhs. Let's say, so I will write it down. I'll keep the number simple. 5, 6, and 4, 3, and 7. Okay, I think I might have made it 0 in some way. Okay, 3 and 3, let's say. And let's say it's 1. Okay, let's do it. Okay, so we have two categories over here, right? Delhi and Mumbai. So another thing, it's again very subjective. You can consider any of them as 0 and any of them as 1. Let's suppose I am considering Delhi as 0, Mumbai as 1. Some other person can come and say, no, I will take Delhi as 1 and Mumbai as 0. You can do it, not a problem. Okay, it's up to you, whichever city you want to put 0 on, put 1 on. So two categories, you can label any of them as 0 and any of them as 1. Okay, so for this we have one measure which is called point biserial correlation coefficient. Correlation coefficient. Okay, so Yeah, I might provide you with the new formula rather than what's covered in lecture, but that again would give you the same answer. RPB, that's how we denote it. Let's say it's the mean of zeroth category. Okay, I will show you what these terms are. And square root of, let's say, P0, P1. Okay. Okay, so which values belongs to the zeroth category? Delhi I am denoting by 0, right? This value belongs to zeroth category, right? This value belongs to zeroth category. This also belongs to zeroth category, right? And for first category, I can say only these two are here, right? Is it clear till this step?
Yes, sir.
Okay,
Yes.
so y0 bar is the mean of values of zeroth category. So mean of zeroth category is 5. 5 is belongs to zero category, right? Then 6, then 1, right? By 3, it's gonna be
3.
4.
Oy.
Okay, it's gonna be 4. Okay, y1 bar, two values. Okay, let me again switch to that color. You can visualize it a better way. Okay, y1 bar, this value. Okay, I can see. This value belongs to first category. This belongs to first category, right? So y1 bar is equals 3 plus 3 over 2. It is 3, right? So y0 bar is the mean of zeroth category values. Y1 bar is the mean of numerical values corresponding to first category. Is it clear till this step? We have computed this portion.
Just a doubt.
Yeah.
We are allotting 1 and 0 to Delhi and Mumbai. Will there be a difference if you're going to interchange the values, like Mumbai as 1 and Delhi as 0?
The sign of your coefficient will change. That's the only difference, right?
Okay. All right. But the answer will be acceptable.
Yeah, answer will be acceptable. So, okay, I will clarify that thing also in the last. Okay. So we have computed the numerator, right? P0. P0 is the proportion of values belonging to zeroth category. So in total, how many values I have in my data set?
7,
5.
sir.
5, right? 1, 2, 3, 4, 5, right?
Oh, sorry, 5, 5. Yeah, 5, 5.
How many belongs to zeroth category?
3.
4.
Okay, it's first, second, and fourth observation 3, right? So P0 is 0.6. P1, proportion of values which belong to first category. In total, I have 5, 2 belongs to first category, it's 0.4, right? Okay. So we have computed these two terms also. We are only left with the denominator. Okay, what's the denominator? Denominator is the population standard deviation of numerical variable.
Will it not be sample standard deviation?
No, it would be population. See, that's what I said. I will give you a different formula than covered in the lecture. And I will show you also both are same. I will show you. Okay. So sigma, so my denominator would be population standard deviation of this numerical variable, which means it would be population standard deviation of these 5 value. Okay. So just to clear the confusion part, in ma'am's lecture, what ma'am did is, okay, so Professor Usha ma'am has computed y0 bar, y1 bar the same way, right? But instead of P0 being, proportion of values 3 by 5, she has taken P0 as 3 by n minus 1 and P1 be the same. So it's 5 minus 1, 4. If you do that, if you do this n minus 1, then you can take sample standard deviation in denominator.
So when sample standard deviation?
Okay, so here how we are computing the proportion? number of observation in zeroth category upon total number of observation, right?
Yes.
How we are computing P1, number of observation in first category divided by total number of observation, right?
Yes.
So your P0 into P1 would be N0 into N1 by N square, right?
Yes, sir.
Right. So instead of this, if you do like this, if you take N0 into N1 divided by N into N minus 1, if you do that, then you have to take sample standard deviation in denominator. But if you
Okay.
proceed with this way, you have to take population standard deviation. So
Okay.
it's better if you take to population standard deviation, right? It's pretty
So
easy
n
to
into n minus 1, we will take it in the case of sample correction.
which
Minus
which thing?
for sample correction, there is n into n minus 1.
Yeah. So, but if you take the population one, you don't have to do sample correction.
Oh. Answer will be the same now.
Answer will be the same. Why would it be the same? Okay, let me show you. In population standard deviation, you will have a term root 1 over n in denominator, right? Right? For in case of population standard deviation. And here you will have n naught n1 times n squared into n. So your this n gets cancelled out, right? While in the case of sample standard deviation, you will have a term 1 over n minus 1 in denominator, right? And if you are taking sample standard deviation, your P0 into P1 would be this. So your n minus 1 gets cancelled out. Both are the same, right?
Yes, sir.
So if you are taking population standard deviation, you can complete the proportions directly. But if you are taking sample standard deviation, you need to do the sample correction by multiplying by n minus 1. That's all. You will
Can
get the
we
same
do
answer.
Now, whether to take sample or population will be our choice always.
Your choice. Depending on that, you will change the value of P0 into P1.
Okay.
Actually, I am not getting this multiplying n minus 1, but actually I am getting the population standard deviation. So is it will okay to just remember the population standard
Yeah, you
deviation?
can proceed with the population standard deviation. So I think that
Okay, sir.
method would be quite easy rather than otherwise you might go
Yes, sir.
confused between n minus 1 or something, right? Just stick to
Yes,
population
sir. Yes.
standard deviation one. Okay.
Sir, hello.
Yeah.
Sir, is there any typical type of question in such type of question while solving, we have to take the population standard deviation, and in some question we have to take the
No.
sample standard deviation?
It's completely up to you. You will get the same answer. Okay.
Sir,
Yeah.
can you explain what is the correction, sir? Because in some question they might give the sample standard deviation and ask us to compute the correlation. So I don't understand what the correction was, the multiplication part.
Correction was okay. See, if you go by this formula, I written in purple color, right?
Yes, sir.
P0 is the proportion of points belonging to zeroth category, right? It would be
Yes.
number of points in zeroth category upon total number of points, right?
Yes, sir.
P1 would be proportion of points in first category divided by total number of numbers, right?
Yes, sir.
That term would be in numerator, right?
Yes, sir.
And if I take population standard deviation, I would have this term, right?
Yes, sir. Yes,
This
sir.
NN gets cancelled out, right?
Oh, okay, sir.
Okay.
So
But if you take sample standard deviation, you will have n minus 1 in the denominator, right? So to get it
yes, sir.
cancelled out, instead of second n, you will take n minus 1. So it gets cancelled out.
So we're directly multiplying the n
Yeah.
for correction. Okay, sir.
Okay. So it's the same thing. The best easiest way is to take population standard deviation and compute proportion as you used to compute. That's all, right? Don't confuse
Okay,
it with sample standard deviation one. Okay.
okay, sir. Thank you.
I'm really sorry. If you don't mind, can you repeat that correction part? Like I didn't really get it.
Okay. So you remember in sample standard deviation we have 1 over n minus 1 instead of 1 over n, right?
Yeah.
So if I'm taking sample standard deviation, I would have this term in the denominator, right?
Okay.
And numerator I had if I'm computing proportions, right? So logically I should have n naught by n into n1 by n, right? But what happens in this case is my denominator don't get cancelled out. So to make it cancel out, I will make 1 n as n minus 1. So this term gets cancelled out. This is called correction.
I mean, you will make 1 n minus. I mean, you are multiplying it.
Yeah, instead of n into n, I will make n into n minus 1. So this n minus 1 factor gets cancelled out.
I mean, when do we really face this kind of situation?
When you are using sample standard deviation in denominator instead of population standard deviation in point biserial correlation coefficient.
Okay, and we can always stick to the one which you taught earlier, the first one.
Yeah, you can stick to the population standard deviation and compute proportion as we used to compute. That would be easiest one.
Yeah.
Let's not use it. Okay.
Okay, thank you.
Okay. Okay. Again, the range part would be the same. It's again lies between -1 to 1, and it also has the same distribution for absence, weak, moderate, and strong. Okay. So
And then what do we denote R square? What is R square?
okay, R square we will come to. Okay. So
Okay.
so it also has the same.
By
And
is also correlation coefficient range.
one thing to remember is okay, it also what was that? It also tells you the same thing. Missing out something, I think. Slice between -1 to 1. Yeah. So yeah, as I took Delhi as 0, Mumbai as 1, right? Okay, let me write down formula first. Y0 bar minus Y1 bar divided by sample standard deviation of numerical variable into P0 P1, right? Just tell me quickly, can this term be negative ever?
No, sir.
No. Standard deviation is always positive, right?
Yes, sir.
Can this term be negative ever?
No, sir.
No, only the
Always
mean
positive.
will be negative.
Only this term
Yeah.
can either be positive or negative, right?
Yes, sir.
So okay, so here if you notice in our question, I took Delhi as 0 and Mumbai as 1. So this term comes out to be 1, right? It's positive, right?
Yes, sir.
Suppose second guy comes and take Delhi as 1 and Mumbai as 0. In that case, my that term would be -1, right?
Yes, sir.
So you will get the same answer, but sign get changed if you change the labels, right?
Yes, sir.
So one can do it either way, right? So you
Yes, sir.
depending on what labels you take, you will get positive or negative value. So in exam, okay, we will always ask you for absolute value. Absolute value means you need to whatever you need to ignore the sign. If you are getting -0.25, you still need to input 0.25. That's what absolute value means, right?
Yes, sir.
So you all get the same answer. To avoid this ambiguity part, we ask you for absolute value always. So be sure. I have noticed many of you still answer the negative.
Sir,
Yeah.
that y naught minus y bar will be negative means it favors sales in Mumbai, I think.
It favors.
Favors means the sales is high in Mumbai.
No. You have to compute the complete. You need to compute. Yeah, I think. But that part, if it's negative, yeah, you will say that in the first category there is more sales than the zeroth category. If it's negative, if it's positive, there is more sales in the zeroth category than the first. Yeah. Okay.
So that y0 minus y1 bar is
Yeah.
always in mode.
No. If you change the label, the sign of y0 bar minus y1 bar will change always, right?
Yeah.
So to avoid this, like we give you this question, right, and we expect all of you to answer the same, right, and we can't restrict you to take this as 0, this as 1. So we always ask for absolute value.
Okay.
Absolute value means whatever value you are getting, you need to only enter the positive. Even if you are getting negative value, you need to enter only positive.
Okay, if in the question absolute is
Yeah,
given, then we have to give a positive value for point
positive
by
value. Yeah, yeah.
yeah.
It will always
Okay.
be asked absolute. Okay.
Okay, sir.
Okay. I think yes. I think one of you mentioned if we square the yeah.
Sir, in qualifiers, do we have to calculate like all these, in calculating point by serial, it involves a lot of calculation.
But
So,
calculation part would be pretty easy. You can do it even manually. That's how easy
Acha.
calculation you will see.
Yeah, actually, it takes a lot of time doing it by calculator, like when it comes to points.
Yeah, yeah, we are aware of that. That's why you will get very easy calculation.
And sir, like how many questions were asked?
It's around 15 with equal weightage to all 4 weeks,
Okay.
approximately, I think.
And 1 hour time.
Yeah, the max time, I think, most of the question would be conceptual, right? Like we did one for correlation coefficient, right? But would be the possible value of population covariance. Such kind
Right,
of
right.
question hardly takes 1 minute, right? So most of people going to be conceptual. So you would be able to do it in 45-50 minutes. Okay.
Okay, so thank you.
Okay, yeah. So one of you mentioned if I square correlation coefficient, I get some capital R square, right? So capital R square is another term called as coefficient of determination. So it's again not covered much in the stats one. So it's again not much to be focused on. It tells you about how good your fit is. You will see such in machine learning courses, hopefully. But yeah, this is coefficient of determination. It is just the square of correlation coefficient. It tells you how good your fit is. How good are my fit is? Suppose these are my points, right? Suppose one comes and plot this line. Okay. Other person comes and plot this line. So which line is better for my data points?
Next one, R square.
Red one, right? So if you compute, so these are just a measure of it. I will not go much in detail, but yeah, that's the only thing it can take care of. Okay. Okay, I think that's all from week 4 as far as I recall. Okay.
Sir,
Yeah.
sir, what does negative and positive mean in between numerical variables? If they are negative, what does it mean?
Two numerical variables.
Yeah.
Negative means if one variable is increasing, other would decrease. If one is decreasing, other would increase. They would have some kind of negative association. Increase in one would cause decrease in other. While if it's positive, it means increase in one would cause increase in one other, and decrease in one would cause decrease in other. That's positive relationship.
Same signs and different signs.
Yeah.
In
Sir,
mark
sir,
question,
there is a question in Mark 2.
Okay.
Given the relation is positive,
Hmm.
and in options it is given that if x value is smaller, then y value will be larger, and vice versa. Two options have been given, and they are right.
Okay. Can you repeat the question a bit? If I can write it down, can you please repeat?
Yes. The correlation was found
Okay.
to be R is equal to 0.86 between price X and demand of mobile
Okay.
phones 5. Which
Okay.
of the following options could be true?
Okay.
Given two plot points from the scatter plot of price and demand of mobile phone, one point has
Okay.
a smaller x value and larger y value than other point. Given 2 points from the scatter plot of price and demand of mobile phones, one point has larger x value and a smaller y value than other point. The covariance of price and demand is positive. It's negative.
Okay. Again, the same thing. So you can see this is positive, right? Strong positive linear relationship, right?
Yes.
And sir, correlation coefficient always greater than 75, no sir.
Always greater than, no. If it's strongly influenced,
0.75.
No
then
sir,
it would
means
be,
it is linearly related only if it is greater than 0.75.
no, greater than or equal to 0.25 absolute value. We discussed the range thing, right?
Sir, like if R equals to 0.49, then it is like what?
Weak,
Positive
weak,
and weak or
positive
moderate?
and weak. It will become moderate if it touches 0.50 only, okay?
Okay.
Okay, let me
I have a doubt. I have a
yeah.
doubt. I don't know if that's really, I mean, if it's relevant. But see, since we are taking absolute value of R, how does sign really matter here?
No, I'm just telling you if absolute value of, okay, let me show you the sign chart also. I think we did it today only. Okay, hope it's somewhat, yeah, this is the chart, right? If you see this region, I think let me switch to that color pen again. Yeah, if you see this region, right?
Yeah.
This is the region where absolute value of R is between 0.25 and 0.50, right?
Yes.
Absolute value. So if you open it, you will get value of R being in this region in negative side and being in this region in positive side.
Okay.
So based on sign, you can say positive, negative, and strength would be moderate.
Yes.
Moderate, oh no, strength would be weak, right? Weak, not moderate.
Oh yeah.
Weak,
Okay.
okay, so yeah, I'm just generalizing it. Instead of writing two equation, I'm writing it as merging as one, right? That's the only thing I'm doing by
And
absolute
sir,
value.
per point by serial, it should be 0.75, greater than or equal to 0.75. Otherwise,
No,
it will not be related.
no, it's the same relationship for them again. If it's greater than 0.75, it's strong relationship.
Sir, per point by serial, sir.
Yeah, point by serial also, it's the same ranges.
Sir, but I remember, sir, there is some note. If the point by serial belongs to 0.75 to 1, then they are strongly influenced,
Yeah,
otherwise not.
strongly. It means there is strong relationship, right? A
But
strong relationship
probably
is when
you have
it's
said that
0.75 to
otherwise
1.
not, sir.
Strong. Otherwise, it's not strong, right?
Sir, but weak, moderate, such kind you have not discussed for point by serial, sir.
I told you it's the same range.
Sir,
Yes, sir.
this moderate weak also apply on that, sir.
Yeah, same. All these same ranges apply on that also.
Okay,
Okay.
sir. But somehow I noted that for that we have to not consider. Sorry, sir.
Okay. Coming back to this question, yeah. Okay. Suppose if it's perfectly one, if R is equals to 1, what would happen? All my points will lie on this line, right?
Yeah.
But here it's R is 0.86, right? It means it's somewhat not exactly the perfect. I might have some points here, I might have some points here, here, here also, right? It will not be perfectly on this line, right? So as per the question statement, there would be some 2 points for which you will have x small and large y, and similarly this. So there would be some point if you compare these 2 points. Okay, let me just show you if I can. Small x and large y. Small x and large y. Right. If I compare these 2 points, let me highlight it a bit for you. This point and this point, right? if you see with increase in x, my y is also increasing, right? That's what 0.86 means, right? But notice this point. This point has small value of x as compared to this point, right? But value of y is greater for this point as compared to this point. So there is one point where you have smaller x and large value of y as compared to other. And vice versa is also true. So r equal to 0.86 means it's not perfectly linear relationship. You could have one such case also. Okay.
Okay.
Okay, I think that's all for today. We can wrap it up. Mock solutions will be released. I think mock session link we will also provide you, so you can refer that. We have discussed all the questions over there.
Sir, this one, sir,
yeah,
mean and the variance are given for two sets. When you combine sets, what is the variance?
what is the variance? Okay, I will give you a hint for it. I think probably you can proceed further.
Yes,
So
sir.
we have a direct formula for it also, but direct formula is not the part of course, so I will not go into that, right? Okay.
No, I somewhere I saw, sir, that n1 sigma 1 plus n2 sigma 2 divided by n1 plus n2 plus n1 into n2 x1 bar minus x2 bar the whole square divided by n1 plus n2.
Okay, so suppose the first one checked these papers, right? And they had mean this, so their population variance would be given by this, right?
Yes, sir.
And second one would check and let's say I'm denoted by y.
N also will change, sir. N1, N2 or Nx, Ny.
Okay. So n1, n2, okay, let's say these are x1, xi1, let's say xi2 and x2 bar, right?
Yeah.
Okay. Okay. Or let me just simplify a bit one. So here my I goes from 1 to n1, okay? And here my I goes from remaining n1 plus 1 to n2. So in total I have n observations. Okay?
Yes.
Okay. Okay. So to find the combined variance of these n observation, right? What would be the formula? 1 over n summation I goes from 1 to n xi minus x bar squared, right? Right?
Correct,
So
correct.
this x bar would be the combined mean.
Yeah, we can find that.
You have find it in the first question already, right?
Yes, sir.
Okay. 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 Can we split it into two parts? Let's say I'm adding it, right? Already. So I can say I goes from 1 to n1 xi minus x bar squared plus the remaining observation n1 plus 1 xi minus x bar squared, right? I can
Okay.
split this summation, right?
Yes, sir.
Okay. Okay, once we split, now for the first term, I goes from 1 to n1. Can I add and subtract x1 bar to this? It won't make any difference, right?
Yes, the addition does not change this.
No, adding and subtracting. It gets cancelled out anyway, right?
Sorry to interrupt.
Yeah.
See the average, the x bar that we found there.
Yeah.
How do we find, like, we just calculate the x1 bar plus x2 bar by 2, or should we consider the entire population and then divide that by n plus, n plus 1 till n2?
Which one you are referring?
No, like earlier you put that as two different formulas. One xi minus x 1 bar, and then
Yeah,
on the top, yeah, yeah.
yeah,
So x1 bar and x2 bar, and then your
yeah,
combined mean. So how do we
yeah.
calculate the combined mean? That's my question. Like, should it be the entire population, or should it be
Mhm.
this x1 bar plus x2 bar by 2?
Okay, so your combined would be sum of all observation divided by number of observation, right?
All.
I can split it like as I goes from 1 to n, right?
Okay,
So I can split it going 1 from n1 xi plus
okay,
n1 plus 1 to n2 xi, right?
okay,
Denominator is n. N is nothing but n1 plus n2, right?
yeah,
And I know their individual means, right? So this term, can I write it as n1 times x1 bar?
okay,
Because what is my x1 bar? X1 bar is 1 over n1 summation I goes from 1 to n1 xi, right?
okay.
Summation term would be n1 x1 bar. Similarly, second term would be n2 times x2 bar.
I just have a doubt there.
Yeah,
N2, like N2 is from N1 plus, I mean, I just don't get that. Will it be from 1 to N2? Then again, so for example, if let's make use of
okay, okay.
numbers. Yeah,
Okay, let me tell you. What happened is in a class there were 50 papers, okay?
okay,
30 went to first teacher and 20 went to second teacher.
sure, okay,
Okay, so my n1 is 30, n2 is like
20,
n1 30 means like all the papers from roll number 1 to 30, let's say. We can
okay,
assume it, right? Then
uh,
remaining roll number 31 to 50 goes to second teacher, right?
okay. Oh,
So
so that's
I
the,
need to sum the scores of all this 50 paper, right? So I
all
can
right,
split it.
sure,
First 30 paper sum and next 20 paper sums,
all
right?
right, all right, all right,
Divided by
okay,
total.
all
I
right,
know the mean of these 30 papers.
okay,
So I know that mean of first 30 paper would be 1 over n1 times sum of scores in those 30 paper, right?
yes,
So summation term would be n1 times x1 bar. So I
okay,
can replace that. And second term I can replace n2 x2 bar, right?
okay,
And in the question we know n1, we know n2, we know x1 bar, we know x2 bar. We can compute this combined mean, right?
all right,
Right. Then comes to population variance thing. So population variance of all the 50 papers would be 1 over n. Then we need to take deviation of each observation from the mean of those 50 scores, right? And then square it and add it. So here also what I am doing is first I am taking the sum of first 30 observation and then next 20, right?
okay, okay,
And then in the first 30 I am adding and subtracting their respective means
yeah, this
x1
I
and x2.
understood, okay,
Okay. Then again, okay, you can check. I won't write it completely. It will come out to be xi minus x1 bar square plus n1 times x1 bar minus x bar squared. If I open this term, okay, I is equals to n1 plus 1 to n2 xi minus x2 bar square plus n2 times x2 bar minus x bar square. Okay, so again you can notice that my this, okay, let me just highlight it, but this term would be n1 times population variance of first data set. This term would be n2 times population variance of second data set, and by these two terms, okay, I don't know which color it is, same means the same, right? So this was the complete formula. In the given question, we know population variance for both individually, we know the means individually. Combined means we have computed. N1, N2 is known to us, and you can write it as N1 plus N2. If all is known to you, you can compute the combined variance also, right?
Sir, this is very tedious calculation. And which type of question was there for such calculation, sir? Is
It's
I
it's
don't
in the,
think.
I think previous September term qualifier. Yeah, you won't see such questions in this term paper for sure. Okay, it was just one
Oh,
time question. Okay.
okay, sir.
Sir, I have a
So
doubt.
yeah,
But how someone got the previous September term qualifier paper?
I don't know. Many of you have it circulating in Telegram group or something. I'm not sure, but you can ask whoever they can share among you. So you all okay? Okay.
Okay.
Yeah.
Sir, I'll just take 1 minute, 1 second of your time. Yeah, we need
Yeah.
not
Please.
discuss fully, but my observation and my problem I'm just sharing it with you, sir. That
Okay.
question number 13, where this A, B, C, D were given, no, sir. We have to find the number mock 1, mock 2. They
Okay.
have asked mock 2, one question they have asked, question
Yeah.
number 13.
Hmm. Okay.
In that, they are asking us to find
Population standard deviation.
no, not that one, sorry.
First test.
Uh, first test.
Mhm. Okay,
First
this one.
test.
Yeah.
First test in my number is
It's same for everyone.
13. 13, yeah.
This one, right?
Statistics. No, this is one, sir. Mock test one.
Mhm.
13. Just a second, sir.
So in the meantime,
No,
may
it
I
is
ask a
Mark
question,
2,
sir?
sir.
Two. Okay.
Mark 2. 70 is the answer.
70 is the answer. Okay, I'm not sure.
There were actually four A, B, C, and D. They,
Mhm.
it's okay. It's a set theory. Okay, sorry, sir.
Okay, it's fine.
Sorry, not in this one. Okay, it's
Sir,
max. I just
Okay,
sorry
okay.
for that.
No worries. No
Okay,
worries.
sorry.
Yeah.
sir, in graded assignment for question number 6, we
Mhm.
have to tell the linear relationship between 1 plus and BBK electrons,
Yeah.
right? So for that, we need to find the correlation coefficient.
Yeah.
So,
Because both are
uh,
numerical. Yeah.
right. So I got it as 0.49,
0.49. Okay.
and I marked the answers as weak and positive,
Yeah.
but it is like accepted answers are positive and moderate.
Okay. What's the range for this fifth question for you?
0.47, 0.5.
Okay. So if it's 0.47, 0.53, it means the exact answer should be 0.50. So while rounding off, you might have rounded off to 0.49, while the actual rounding off should be 0.50. So for 0.50, it's moderate.
Sir, but it's so boundary case.
No. If you just check the third decimal place, it would be greater than or equal to 5. So rounding off, it would
I
become
think it's
0.5.
0.4993, sir. But I
0.4993, right? It's 0.50.
just omitted 93 and mark it as
Yeah.
0.
Okay. So yeah, in quizzes, that won't be such. But these are like each one of you get random numbers, right? So it's
Right.
possible some of you might get some complicated ones.
Excuse
It's
me,
okay.
sir.
Yeah.
Yes.
Sir, I have a doubt in graded assignment, the fifth week.
Fifth week we
So
will do
grade.
it. Okay. Fifth week we'll do it. Let's focus today on first 4 weeks only. Okay. I mean majorly on the fourth week. Fifth week we'll do it.
This
Sir,
mock
one
test
request.
2, 18, that call center 75 employees.
Which one?
Sir, one
Mock test
request is
2,
Mm-hmm.
mock test 2, question number 18.
sir, could you
The
please provide the PDF of the revision that you have just taught?
I think it's the complete whiteboard. I'm not sure if I can share it. Do you guys want this? Sure.
Also, sir,
Actually, sir, we have not attended the lecture, so we have to watch a whole lecture from starting. I think it would be better if you could share the slides.
Okay, I will
Due
share
to
you, but
CT, sir,
it's
we have
won't
not
be
watched
some
all.
complicated. Okay, it's
Yes, sir.
very complicated, but you want, I can share. Okay, it's not an issue.
Also, sir, like you shared,
Sir, that only is 18.
sir,
Yeah.
like you
Also, sir.
shared week 1 and week 2
There are
revision
only 2
notes.
points,
Can
sir.
you share for
Let,
week 3?
let him. Yeah.
Oh,
There are.
sorry.
There are.
Sir, like you shared week 1 and week 2 revision notes, can you share it of week 3 and week 4?
It's in preparation. We will share it as soon as we complete it. It's under preparation for now. Okay.
Okay, sir.
Sir,
Okay.
there is a
So
set of, sorry to stop, sir. So there is
yeah.
a set of EMQs which I think the deadline is something somewhere in December, but it is also mentioned that you have submitted before quiz one. I'm not able to understand that, sir.
Oh, this one is still December. Graded one, you have to do it till the deadline. Okay.
So which one, sir? Can you just show? Your screen is
This
open, so
one's
you can.
okay. Week 6 or something, right?
No, sir. I think somewhere in between. Like this is the new set. There is one more set above, sir.
Week 5.
Oh, one moment, sir. Just allow me. I'll just unmute and then I will.
12th October, right?
No, not this one, sir. Just 1 second, sir. I'm sorry. Just 1 second. Let me just. I'll let you know. Just give me a minute.
Okay, so the call center one, again, you have to find the combined mean we discussed today. Just try to do it again. We will release the
No,
solution and provide you
the
with the
mean is
explained
okay, sir.
everything
The
video.
relationship you are telling me, sir. Mean is okay. I got that answer.
Okay, mean is okay. Okay,
Mean
relationship you
is
want to know,
okay.
right?
The correlation coefficient of time and cost is negative, they are telling. But there are only two. One is first part early AM and PM. And since it is per hour, so 10 calls per hour. So the straight line, it will be a straight line from 9 AM to 1
Yeah,
PM. There will be
see, in
X
9
will be
AM to 1
constant.
PM, the average was 15. Later, it reduced to 5, right?
Yeah, 15,
So
15,
it
15,
means
1
there is
hour.
negative. No, it's not 15 for all. Average is 15.
Sir, one doubt in this
Okay, but
question
still
also, sir.
we don't know, no, sir.
Working
Average is
hour is 9 to
15.
6 p.m.
From average 15, the, you mean to say it has come down to, what is the answer we got?
Yeah, the
Yeah.
well decreasing, right? It's negative and decreasing.
Sir, here
I did
clearly
not
mentioned
answer it.
working hour is 9 to
Correlation
6.
sign means
Then
is
why we
negative.
consider 8 hour only, sir?
Because it's given it's lunch break from 1 to 2, right?
But it is clearly mentioning working hour is 9 to 6. Then
You
why
have
we need
lunch
to?
break and working hours only, right?
Yes, sir. So we should consider no that lunch break also
No, in
because
lunch
it
break
is
means no video calls, no calls, right? Nothing else.
okay, sir.
So
Okay, yeah.
the EMQ I was mentioning is in the one between third and fourth graded assignment.
Yeah, these are practice assignments. You can attempt it by any time you want. Okay.
So, but उसमें लिखा है the
It talks
assignment
about the
won't be
slope of the trend line is negative also. Same, sir.
this
Yeah.
assignment won't be considered for course participation marks after 16th October. So I'm not
For
able to
bonus marks, it would be it's for bonus marks, but you are open to submit it till the end of the term. Okay.
means I can attempt it after 16th also.
After 16th also, but it won't be considered for bonus marks in that case. Okay.
Okay, got it. Fine, got it. Thank you so much.
Okay.
Excuse me, sir.
Yeah.
Thank you, sir. Thank you. I am leaving, sir. Thank you.
Sir, according to you, sir, the level of qualified exams, would it be like that of the mock test or would it be a level up?
Okay. I can't say exactly about the level, but yeah, it would be conceptual based question. Mostly if you're clear with the concept, it's gonna be an easy one. Okay.
And sir,
Okay, sir.
where
And
Calculation
PDF
would
will
be
be there
easy. Yeah.
okay, sir. And also,
and
sir,
PDF
about
of
the
this.
calculator, would there be any kind
TCS
of
calculator.
lag or
TCS
something?
calculator only. On-screen TCS calculator. Okay.
Uh, and sir, could you please remind that about that CT mock test? It's already deadline has passed, so if you could just extend it.
Yeah, I will ask the team to extend it. Okay.
Yeah,
Okay,
sir.
sir.
Thank you,
Thank
sir.
you, sir. And a
Okay.
PDF will be available on portal, sir.
This whiteboard PDF you want? Okay, we can make it available.
Yes, sir. Yes, sir.
Okay, I will make it
Send.
available.
Okay, sir. On portal we will get, sir.
Yeah, on bottom. Supplementary contents. Okay.
Okay, sir. Okay, sir. Thank you,
Okay.
sir. Please
Yeah.
provide it
Thank
soon,
you.
sir.
Yeah.
Excuse me, sir.
Yeah.
Sir, I am a JE-based student. Sir,
Okay.
suppose if I want to take admission in January batch, so what
You
will be the procedure for
can
that?
just clear the qualifier and you can enroll in the next term. It's completely up to you. Okay.
But sir, week 5th and 6th, the
You
deadlines
don't
are
have to submit.
okay. So if I
You will
don't
do
submit this now,
you will do it all again from week 1 in Jan term. Okay.
week 1 again.
Yeah. You will do it all from starting in Jan term.
Okay, sir. So will there be any different procedure or just apply? For
Yeah,
my batch only.
just write to support team. They will guide you better on it. Okay.
Okay, sir. Thank you.
Okay, I think that's
Sir,
up to
sir,
yeah.
sir, I
The
have two
support team,
things, just
can I
small
get
two
the
things.
name?
So can I go ahead with that?
Yeah.
Okay, sir, there is a small doubt about the particular thing that I found in a question. It was saying three categories, one with professor and certain amount was there, and another was associate professor and another was assistant professor, and then we need to find mean and whatever that was.
Yeah,
So sir,
yeah.
this is ordinal data, so how
Ordinal
can
data.
we say which one has higher rank or whatever? Because we
A
don't know.
professor has the highest rank, then it's associate professor, and then it's assistant professor.
Okay, okay, okay. Thank you, sir. So that one is gone. Another one is, sir, from this week. I found this question again and I tried, but I can't get the proper answer. The question says, what is the value of population standard deviation for the first 2n natural numbers?
First one natural number, okay.
2n natural numbers. And we all know the formulas for the first n natural numbers and square of n natural numbers. Those
Yeah,
formulas.
so we did this question in the week 3 revision session. You can go on
Oh, we
YouTube.
did?
In the last you have discussed. Yeah, you can go and
Oh,
check.
okay, okay, okay. Oh, okay, 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 okay. Thank you, sir. Thank you.
I think you are missing the formula is from 1, starting from 1. The formula first 12 that start from 1. And the question say first 12 natural number.
It
And
says
so
2n. It says 2n, not 12. It says 2n. 2
okay,
into
I'm
n.
Okay, yeah. This
okay.
question we have discussed. You can go refer
Okay,
on
okay,
it.
sir. I'll just go through the video. Okay, okay. Thank you, sir.
Okay.
Thanks. Okay, I think we will wrap up for today. Okay.
Sir, excuse me, sir.
Yeah.
So the support team email, can you write that in chat?
Support team email, I think you all might have already heard it. Can any of you type it in the chat? I think I did it. Okay, I've written it in the chat. You can refer. Okay.
So one last doubt. Thank you.
Yeah, please ask. One last out. Who is?
Am I audible?
Yeah, you're audible.
Sir, it is written in the hall ticket that we are not supposed to bring any sort of bag or something. But since I don't
You can
stay
keep it
in the
outside. You can
center,
keep it outside. There would be
so will
space
that be safe?
provided.
Because it is
Yeah,
written
yeah.
you have to keep it on your own risk.
Okay,
So will that be okay to bring a bag?
Yeah, it's okay. There is security and you can keep it. But yeah, it's
Okay. Thank you, sir.
okay. Yeah. Okay. Thank you, everyone. Good luck. Do your best. Okay.
Thank you so very much,
Thank
sir.
you, sir.
Thank you, sir. Thank you, sir. Thank you, sir.